All right, everybody. So let's take a minute to talk about where we've been and then where we're going to go. So I have just made this video about the basic concept and notation and vocabulary regarding an antiderivative. So we've got to have a firm footing on that before I can go now and show you about the rules for calculating an antiderivative. Okay? But that is what I want to do now, is tell you about those rules. So I might interpret this problem right here. Okay, so let's say this is my first example, but I might interpret this entire expression as a question like so. What is the antiderivative of that function that's there? And I can say it's a function of y, so f of y means it's a function of y. It's a formula. It's a function where y is the variable of root y. Okay, so I can interpret it that way. Now, maybe you could figure this out without any rules at all. You know, some people can do that. Depends on how good you are at math. Most people need rules. Okay, so let's talk about what the rules are. Most basic rule, probably the most common rule that we'll use as we go through this, is the rule for the antiderivative of x, supposing that x is our variable, to some power n. N is any constant power, but it can't be -1. It could be anything else. It could be a fraction, decimal, it could be a whole number, it could be a negative number. But the antiderivative of x to some power n is x to the power n plus 1 divided by n plus 1 and then plus c. What's that capital C? It's the constant of integration. Okay, we talked about constant of integration in the last video, but there's our rule. Okay, notice how all my answers have that plus c. Okay, if you're not sure what the plus c means, go back to that video I referenced just a minute ago, and it's all explained right there. Now, this appears to be a rule that would be applicable to this problem, maybe with some rewriting. Let's see. So I say this rule says, here's how you can find the antiderivative of x to some power n, given that x is the variable. If the variable is y, the rule would still apply, but I don't see a power. Okay, there's no exponent. Like this one right here. This one has an exponent. The exponent is 4/3. But there's a conversion between roots and powers in algebra, okay? All right, so I could say, well, if to make this a little more appropriate for what my rule says, I'll look at this as y to the 1/2 power dy, okay? All right, now that'd be more like it. The rule for conversion between roots to fractional exponents is that if we said, like, I've got some number x to the power a over b, that power is a fraction, can be interpreted as the b root of x to the a power. So when I see the square root of x, the square root is the second root. And I know that there's no power in there on the y or the x, but, you know, I mean, it's not that there's no power, it's just the power's 1. And so that's why the square root of any number, any variable, is that number or variable to the 1/2 power by this rule. So do you see the equivalence between my general rule and like this particular example of the square root of y? Okay. So now I get this. Now I do see a power. It says y to the 1/2 power. And that rule says that I would just add 1 to that power and divide by that same number, n plus 1, x to the n plus 1 power over n plus 1. So, all right, that's something I should be able to do. Let's see. So it would be y, and I take that power and I add 1. And then I divide by that same result, and then I add my constant of integration. Okay, all right. Now we'll do some calculations. I would want to say in my answer, what is 1/2 plus 1? And that will be 3 over 2. Okay, so then I get like this, 3 over 2 down there also. And this, I guess, is technically right. I mean, that's my antiderivative. But we have conventional ways that we write things, and it's seen as a little bit awkward to write this division by a fraction. So how can I simplify that? Like, what do we actually mean if I say I have something and I'm dividing by the fraction 3 over 2? Well, to divide by a fraction is the same thing as to multiply by the reciprocal. So I'll get 2/3. Okay, dividing by 3 over 2 is the same as multiplying by 2 over 3. And then times y to the 3 over 2 power plus c. Okay, and then there's my answer. I think that as far as my math lab goes, this would be acceptable. But it's on the chance that we may put our answer back in the form of a root. I want to tell you that it also might be required sometime, or somebody else may expect this from you at some time, to say y to the 3 over 2 power is the square root of y to the 3rd power. Isn't that correct? Why is that correct? Well, because this is our equivalence. This is our rule between fractional powers and roots. So y to the 3 over 2 power is also the square root of y to the 3rd power. All right, so I'll give you both of those just in case. I never know what the future holds, and I want you to know that they're the same. Okay, so I used that rule, right? I used this rule right here. Now let's talk about some of the others. My next example, so it says, what's the antiderivative of 7x to the 4 over 3 power plus root 7? Okay, so there are several things that I have to deal with here. And I'll talk about the rules first and go back to the problem. This rule says if I have a constant, any constant times a function, then the antiderivative of that is just that same constant times whatever the antiderivative of the function is. So it's kind of like this. It's like you could work an example if you had a constant times some function of the variable. It's like you could pull that constant out and just work out the antiderivative of this function by itself. And then once you did that, multiply the answer by the constant. So it's like this constant does not really do anything. It just kind of follows along into the answer. That's what that says. So with this one that I'm about to do, that 7 right there, it's like I don't even have to worry about that. I just have to figure out what's the antiderivative of x to the 4 over 3 power and figure out what that is, whatever it is, and then multiply the answer times 7. Okay? What about the plus, though? What do I do with the plus? So I've got another rule for that. If I have the antiderivative of one function plus or minus another, then it's like I could just work those individually and then either add or subtract the answers together. Okay? So it's kind of like if I have a constant times a function, that constant just follows the problem along and shows up in the answer. And if I have a plus or minus in my antiderivative, then that plus or minus just follows along into the answer. It's not like, it's like you don't do anything with this constant, and you don't do anything with the plus or minus. You just follow them along. Okay, so here's how I'll break this one down. Okay, I'm going to say, well, I'll have the 7, and I'll find the antiderivative of x to the 4/3 power. Okay, and then I'll add whatever the antiderivative of root 7 is. Okay? All right. So now let's go through this. The 7 being a constant as is just going to follow along. How do you find the derivative of x to the 4/3 power? Well, that was with that first rule that I showed you. Right? You just, if you've got x to any power, any constant power except -1, just add 1 to that power and you divide. Okay. So let's see, if I do that, I'll get x, and I'll have 4/3 plus 1, okay? And then down here, I'll get the same thing, 4/3 plus 1. All right, And then I'll work that out in my next step. But this is what I have so far. I carry the plus. Now I have the antiderivative of root 7 dx. Should I, remember, what was that other problem? Remember that other problem we did? Say root y. It's like I needed to see the exponent. Should I do this? 7 to the 1/2 power? Like, no, that wouldn't be the right way to go at all. Remember, once you get to algebra and beyond, we have constants and we have variables. Okay? Y is a variable. It can change. It can take on different values. 7 is always 7. It will never be anything but 7. It's a constant. Okay? So here, like, I don't have a variable. It just says root 7. So let's see. Is there another rule for that? Yes. Rule 2.1. The antiderivative of any constant is going to be that constant times x plus c. Okay? Why is that? Well, the derivative of k times x is k. So quick example of this one. Example. The antiderivative of 4 dx is 4x plus c. See how that works? The derivative of 4x is 4. Antiderivative of 3 dt is 3t plus c. And the derivative of 3t is 3. So the antiderivative of any constant with respect to x, if x is a variable, is going to be that constant times x plus c. So that's the situation I'm in here with the root 7. So we'll say the variable is x. So we'll say root 7x. Okay, then we'll put our plus c, our constant of integration. Now, I wrote root 7 times x, but we have to be careful when we write this kind of thing. Most people do not write root 7 times x because if your handwriting is not good or if the print's too small, it might look like that x is under that bar when it's not. Okay, so I'm gonna stick with the convention, the way that most people would do this. I'm gonna write x times root 7. Same thing, but this way, if I write like that, there's no confusing, like, is the x under the root or not? Is it part of it or not? It's not part of it, okay? So we'll do like that. Now let's see, what else? I guess just some simplifying. Let's see, could this be simplified? Yeah, I could add 4/3 plus 1. I can tell you what that number is. So let's see. I'll get 4/3 plus 1. That happens to be 7/3, okay? And then that's 7/3 also down here. And then I can't simplify this, so I'll just keep writing that, x root 7 and plus c. C is the constant of integration. Now what? Well, remember in that last problem I said I wouldn't just divide by the fraction and leave it like that. It'll probably be simpler if I multiply by the reciprocal, okay? Because to divide by 7/3 is the same thing as multiplying by 3/7, and that will probably simplify it. Now I'm already multiplying by a 7. So I'm going to be multiplying by a 7, and then I'm going to be multiplying by the reciprocal of 7/3, which is 3/7. Okay, and then I have this x that has the power 7/3. So I get like that. Okay, now here I find that some of the numbers do cancel. I have a 7 on top and a 7 on the bottom. See, 7 is 7/1. So I got a 7/1, then I got a 3/7. So 7's cancel, and then I'll get my final answer. Okay, so 3 times x to the power 7/3 plus x root 7, and then plus c. Okay. All right. And then that will probably do it. It might be that we need to be aware about this 7/3 right there, and that would be the same thing as the 3rd root of x to the 7th power. Same thing, right? So maybe we'll write it like that. Just in case, you should know that, but I think this is probably okay. All right. Oh, so now we see that if you have a constant times a function, a formula, whatever that is, you could just carry the constant along with your work. Same thing with a plus or a minus. Okay, so let's see the next problem. What about this one? So this seems to be a combination of everything to me. The variable is t, so that's what the dt tells me. And then I see I got 1 over t to the 9th power minus 3 over root t. And I'm not troubled by the minus because I remember learning in that last problem that we carry pluses and minuses along. Addition and subtraction, we carry those along. This will be a multiplication by 3, really. Okay, so that's not a big deal. But let's do this. Let's write everything like with exponents. Like I need to see everything I have as the variable to a power, not 1 over the variable to a power or something like that. So let's do like this. Let's rewrite this way. For my rules to be applicable, I should see this not as 1 divided by t to the 9th power, but I should understand that as a negative exponent. Okay? It's the same thing to say t to the minus 9 power as it is 1 over t to the 9th power. But the rule is applicable if I write it as t to the minus 9 power. Okay, and then I got this subtraction. Here this says 3 divided by root t. But that would be like 3 divided by t to the 1/2 power if I wanted to see that with an exponent. But I don't want it to be divide. I want to see that you have a variable to a power, not something divided by the variable to a power. So wouldn't it be like this? Could I say this is not 3 divided by t to the 1/2 power? Again, thinking about this now in terms of negative exponents, I could say it's 3 times t to the minus 1/2 power. Okay? So that's the way that I need to see this one. If I get it like this, then I have my rule to be applicable. Whereas it's not applicable the way that I initially had it. All right, now what does the rule say to do at this point? When you have a variable to some constant power, as long as that power is not -1, then we just add 1 to the power and divide. So I think we're to that point, and we could work the problem that way. So I'll get t, and I'll get -9, and I'm supposed to add 1, and then I divide by that very same number. I carry along the minus. What do I do with the 3? I carry along the 3. Okay, that's what those other rules I discussed said. And then same thing right here. I add 1 to that power, and then I divide by that same number. And then I add my constant of integration. Okay, looks like I got it. I just need to clean this up a little bit, all right? Let's see, so I do in fact know some of these numbers. Like I can tell you what's -9 plus 1. That's going to be -8. Okay, so I'm going to get like this. And over here, I'm going to get this 3. And let's figure out what this is. -1/2 plus 1. So that's going to be 1/2. And 1/2, right? Plus c like that. All right. Now I want to write this in the simplest way that I can. And that might be like this. Let's see. This first term's negative, right? So when I divide by -8, that essentially makes it negative. So I might do like this. Say minus t to the -8 power over 8. So that term's negative. Over here, I have a 3 divided by 1/2. I'm dividing by 1 over 2. And what do we say about when you divide by a fraction? You multiply by a reciprocal. So if I have like a 3 over a 1/2, which is what I have here, okay, then that's going to be 3 times 2 over 1. Oh, it's going to be 3 times 2, so it's just going to be 6. So minus 6t to the 1/2 plus c. All right, so there's our answer. That's probably good enough, but there are other ways I could write this, and I want to make sure that you're aware of them. It might be that, you know, my math lab or somebody at some other time would like to see that you can write that as a positive exponent. So I can say this is the same thing as 8 times t to the 8th power like that. Negative 1 over 8 times t to the 8th power. I got an 8 under that bar already. And I could correct this negative exponent by sending that under the bar. And also, right here, what's t to the 1/2? If I were to write that in some other form, that would be the square root of t. Okay, so I'll give you both of those just so you know, just in case in some other time and place you would need to know alternate ways to write that answer. Okay, all right, now let's try this one. Now, this one I notice is different than the others for this reason. Notice that it has a division. It has one function divided by another function. And r is the variable. Okay, so I got one function, 1 plus 4r to the third. That's a formula in terms of variable r all by itself, and it's divided by another. Okay, I don't have any rules for that. Okay, you can, I know how, if you multiply by a constant, not a variable, then I could just carry that constant into the answer. I got rules that say you could carry addition and subtraction into the answer, but I don't have any rule for these two situations. Okay, I have no rule for the antiderivative of one function divided by another function. Okay, so that's what I have here. Functions, not constants, but formulas with variables. And I don't have any rule for one function times another function. So functions, not constants. It's okay if you have a constant times a function, and you could just carry that constant into your answer through your work, but not a function times another function. So I don't have rules for those. I'm not saying that there's no rules at all or that it's impossible to address these situations, but they're beyond our class, okay? And if you were in either of these situations, you have to find some way to get out of that situation. That's what I'm saying. Okay, so I do not have a rule that will allow me to address this. Do I have any other options? Well, it's kind of like this. Let me give you an analogy. So I like analogies. So I'll say, let me see. Let's do like this. So say you had 1/5 plus 4/5. Okay, that would be 1 plus 4 all divided by 5. Okay, it'd be 5/5. Now this is a two-way street. So I can add fractions with a common denominator like this, and I guess I could take them back apart. I want to take this apart like this. You see, 1 plus 4 divided by 5 is individually 1 over 5 plus 4 over 5. That gives me a way that I could take this apart so that it's not one function divided by another, okay? All right, so in other words, we'll see like this. This, by my analogy, is 1 divided by 7r plus 4r to the third divided by 7r. Okay, that's a little bit better. Like now, like I could handle this by my rule. Okay, and I think I can handle this one too with a little more simplifying. Like it's redundant and unnecessary to write r to the third power divided by r. Some of that cancels out. So let's do this. Let's say this is 1 over 7r plus, and this will be 4r squared over 7, right? That's how the r's are going to cancel out of that one. All right, so now we're in good shape. Now, I think that it would be good to separate out some things, okay? Because I have my rule right here that says if I have a constant times a function, then I can find the antiderivative of that function and just multiply it by that constant. So like that constant just carries along. So I want to do that with both of these. I just want to make that a little bit more clear. So I have, for this first one, I could see this as the constant 1 over 7 times 1 over r. That would be 1 divided by 7r, because when you multiply fractions, you multiply them straight across. That's what you do. And then this one I could see as 4 over 7 times r squared. I could see it as 4 over 7 times r squared over 1, and that would give me this. All right, so here's what I need to do. The answer to this is 1 over 7 times whatever the antiderivative of 1 over r is, plus 4 over 7 times whatever the antiderivative of r squared is. Now that one we've handled so far, but not this one. Remember how in another problem I said, well, I would like to see what the exponents are. Like I need to see this as not 1 over t to the 9th power, but t to the minus 9th power. And I need to see this not as 3 over root t, but 3 times t to the minus 1/2 power, and so on. Okay, so this one would be what? What's 1 over r? It would be r to the minus 1 power. Okay, all right, that's what it would be. And it seems like this rule here for x, our variable to a power, would apply to it, but I had this fine print. It's not applicable if that constant, if that exponent is -1. All right, so I can't use that rule that I showed you already. So let's see. What do you do when it is -1? We have this one, the antiderivative of 1 over x dx. Yeah, that would be the case where our variable is to the minus 1 power. So that's what we've got. Let's see. Antiderivative 1 over x dx is natural log of x plus c. All right, that's what we want, okay? I'm going to just take that as a rule. There's a whole big, long story you could tell about the rule, but we're just going to accept the rule, okay? So here goes. My answer here is 1 over 7 times whatever the antiderivative of 1 over r is. That's going to be natural log absolute value of r by that rule I just showed you. Carry my plus, carry my 4 over 7, and then the antiderivative of r squared by the original rule that we learned early on is like this. Add 1 to the power, r to the 3rd over 3. Okay, so I get like that. Let's see, can we simplify it all? I can't simplify this first part. You know, it's just going to be like so. 1 over 7 natural log of absolute value of r plus, over here I'll combine some of the numbers. I've got 4 over 7, and this is like a 1/3, that 3 under the bar, so I'm going to put 4 over 21. So right in here, at least with the numbers, I have 4 over 7 times 1 over 3. That's why I'm saying I get 4 over 21, r to the 3rd power. Okay. All right, now so we found ourselves in new territory with this one, with that part right there. Okay, all right, let's try one more that's a little like this, but maybe a little bit harder. Okay, all right, so here it is. So it has something in common with the last one in that it's one function divided by another, and that we can't have. Okay, I need to reduce that somehow, and like with this one, it was one function divided by another. I had to find some way to separate it out and break it down so that it wasn't like that. And I gave you this. You know, that I said it was like this. That you could add fractions together and you can take them back apart. So I want to do the same thing with this one. First of all, I know that however I do this, it will be important to see what the exponents are. Okay, so let's start there. Like I have root x. Well, you know, however this works out, I'll need to see the exponent. So that's exponent of 1/2, right? And then I got 6. 6 just a number. 6 is a constant. And then I got 3rd root of x. But again, to see the exponent, that's 1/3. Okay. So anyway, I get that, at least as far as seeing the exponent. And then the other thing I learned was that I could break that fraction apart like this. 1 plus 4 over 5 is 1 over 5 plus 4 over 5. It's like that. So in this case, I would see this as, well, each of these things individually is divided by that. So I'm going to get x to the 1/2 power, and then x to the 1/3 power, okay, and then plus 6 over x to the 1/3 power. All right, now this is what I'm dealing with at this point. Now, here, at least where I am now, this is still one function divided by another. And like that's what I needed to avoid, okay? So remember I said that I don't have rules for the antiderivative of one function divided by another or multiplied by another. I'm going to have to, if I'm ever in that situation, I got to break out of it somehow. But same thing here, like remember I had r to the 3rd over r? And I said, well, that some of that cancels, okay? I mean, I got 3 r's on top and 1 on the bottom. That would leave me 2 on the top. I reduced it that way. But you can do that no matter what the powers are. So here I've got like another rule for exponents, okay? That when I take a variable to some power n, and this is just algebra, this is not calculus, okay? This is just algebra regarding how we reduce exponents when we divide. But if I have some variable to a power n divided by that same variable to some other power m, then the way we reduce that is we subtract the powers in this order, n minus n. That would be applicable to this. That's how I would reduce it, okay? All right, so I'm almost there. It's just for my rules to be applicable, I need to see this as x to some power n, right? And it's kind of all jumbled together. So the rule I just gave you said that these could be reduced when you divide like things by subtracting the exponent. So this is going to be 1/2 minus 1/3. And then this is 6 divided by x to the 1/3 power. It's just going to turn that power negative if I move it up here. All right, so this is a little closer to what I actually need to solve this problem. I guess I just have to do one more thing. What is the power on that x? What's 1/2 minus 1/3? Okay, well that's going to be 3 over 6 minus 2 over 6. All right, so 1/2 minus 1/3, common denominator 6, 3 over 6, 2 over 6, 1 over 6, right? Okay, 3 minus 2 is 1 over 6. So I get x power 1 over 6, whoops. Okay, and then plus, and I can just leave this the way it is because it's already the way I need it. X to the minus 1/3. Okay, so now I can use the rule. It's like this step right here. I've worked it out, like rearranged it, got it to the form I need it to be to apply the rule for the antiderivative, which I'll abbreviate AD, okay? Everything else up to this point was just rearranging it, rewriting it so that the rule was applicable, okay? So now I got it to that point. What does the rule say? So here I will add 1 to this power. I'll get 1 over 6 plus 1, and I'll divide by that same number. I carry the plus along. I carry the 6 along. And with this x to the minus 1/3, again, I add 1 to that power, and I divide by what I get. And then, as always, I add my constant of integration. As far as these numbers go, this is going to be, see, 1 over 6 plus 1. That's going to be 7 over 6. Okay? Plus 6. This is going to be, so negative 1/3 plus 1. That's going to be 2/3. Okay, negative 1/3 plus 3/3, 2/3. So then again, 2/3. Like that, plus c. And then from there, let's see, what have we talked about this before? What does it mean to divide by a fraction? In particular, what does it mean to divide by 7 over 6? We'll multiply by the reciprocal. 6 over 7, x to the 7 over 6 power. Okay, over here, same thing. I'm multiplying by 6 though already, and then I'll be multiplying by the reciprocal of 2 over 3, so that'd be times 3 over 2, right? What's that though? That's going to be 18 over 2, or 9, okay? You can also cancel the 2 into the 6, get 3, 3 times 3 is 9, but it's 9. So we'll say plus 9, x to the 2/3 power plus c. Okay, and then there's our final answer. So that's all the rules, okay? I guess that's all the rules except for one. Okay, so here I gave you, we talked about this one, we talked about this one, we talked about this one, talked about all of them except for this fourth one. But in case you were to encounter that, the antiderivative of e to the x dx is e to the x plus c. Is that surprising to you though? I mean, does it make sense that this is the antiderivative? What's true about all these? What's true about all these is you could check your answers, okay? If whatever you're saying the answer is, you could take the derivative of it and get this original function you started with. That's true every single time. That's what would make the answer correct. But for this one, for this fourth rule, what verifies it is that the derivative of e to the x is e to the x. That's one of the rules for derivatives that we learned, okay? But that method of checking, that thought process applies to any of them, no matter how you do them.